Hi, Sochi, Grace, and maybe Brisa. So, I believe last time we talked, we did a little bit of talking about cars, and I figured, hey, why not do that a little more? So, today I will teach you some very basic car vocabulary just for starters, alright? Does that sound okay? So, the very core of the car is, of course, the engine. So, let's start off with the different types of engines. There are two types of engines: piston-driven engines and rotary engines. First type, we'll talk about piston-driven engines and the different types of piston-driven engines. There's a lot of them. So a piston is like just this little thing. Here, I'll draw it for you. So this is a piston. It drives up and down, which in turn leads eventually to your wheels moving. So these pistons are arranged in different ways. There is two main types of piston-driven engines. This one right here is a V engine, and this one here is an inline engine. They do the same thing, they're just arranged in different ways. In an engine with a V shape, the pistons move up and down in this V pattern right here. But in an inline engine, they move slightly differently. The cylinders move up and down in just straight up and down right here, as opposed to an angle like this. Now, V engines can be angled at 22.5 degrees or at a full 45 degrees. There's certain advantages to each, mainly being vibration and spacing. That's the thing. So let's get a little more in-depth about these pistons. This main square part here is the piston, which is connected to a rod. Now a rod is connected to the crankshaft, which is its axis that it rotates around. And there's also a joint usually around the middle that bends, which allows it to go up and down, while this part right here does a circular motion. So a piston sits inside a cylinder. Let's make this a little more up close. So the piston will start in this up position. Let me draw for you guys. Okay, so the first stroke right here is called the intake stroke. That is the piston moving down and drawing in the air and fuel. After that, this is called the compression stroke, where it compresses all that mixture of fuel and oxygen. Then I was reading it backwards. Sorry about that. So this one is the first stroke. This is the intake. This one is the first stroke, it's the intake stroke. This is the compression stroke, compresses that. Then we have what is called can do it. Then this one right here is the power stroke, in which that ratio of fuel and air is ignited and is pushed back down. And then, of course, we have the last stroke that I'll draw for you here, where it is returning back up after the power stroke, and that is the exhaust stroke. Now let's go into these different cycles in a little further detail. So, first step, intake. So this is the position it goes. It's moving in a downward position, starts at the top, moves down, which creates a vacuum, which means it wants to suck air and fuel inward. Now, another important part is how, of course, we get the air and fuel into the engine. So, and fuel and oxygen enter in through these things called valves. Let's draw a valve. This little thing right here is a valve. I don't know if you can see, let's get a little closer. This is a valve. The valve will open. Let's draw it in its open position. So see, look. Over there, it's open and there's a space in which air can go into the engine and enter in for the intake stroke. Now, if it's a carbureted engine, we'll get into that in a little bit. Fuel will also be going in at the same time. If it's fuel injected, it'll enter through a fuel injector at some point during this cycle, during this intake cycle. So next is the compression stroke. So after that intake, it returns back into its upward position. You can see we got fuel and oxygen in here, and this valve is in the closed position. That means that there's nowhere for this oxygen and fuel to escape, which means it gets super hot and it's ready to ignite. And when it's ready to ignite, this is at its topmost position, or wherever the computer of your engine decides. There's a little fuel injector. That's our fuel injector. That's our spark plug. The spark plug makes sparks, which will in turn ignite the gasoline, which leads us into the next part. This is the power stroke. As you can see, it's moved into a downward position due to that explosion in the cylinder that had nowhere to escape. It pushes the piston down, which in turn drives the entire engine. And different pistons in your engine, whether there's 6 cylinders or 4 or 8 or 12 or 16, these power strokes and intake strokes occur at different times, which means one cylinder going down is in its power stroke, but the one on the opposite side might be in its intake stroke. The one going up might be in its compression stroke, and the other one going up might be in its exhaust stroke. Sorry, that was a fly. Also, I need a drink. Okay, so now one of the most important parts, the exhaust. So let's draw this. So if you remember, there was a valve that let the oxygen into the air, but now we gotta somehow get that burnt, bad stuff out of our engine. That is where the exhaust stroke comes into play. So this piston is now moving back at an upward pace, and there's another valve. There's always at least 2 valves in every cylinder in every engine, ever pretty much. So as this is going up, this valve will open downward and allow a place for this exhaust gas to escape, which eventually leads through your car's tailpipe. And that is your basic 4-step compression ignition cycle, also known as the Otto cycle. So let's move on to some other aspects dealing with this basic cycle, okay? So how does fuel and air get into there? So for this, I'll draw a cylinder with a piston in it. Let's do this. So there are different ways air can get into an engine through fuel injection and carburetors. I will do something else involving carburetors because I actually have one that I could just hold in my hand and show you, but for now I'll demonstrate fuel injection. These here, right here, this one right here, and this one are fuel injectors. There's 2 main types of fuel injection within gasoline engines. Port injection, right here, and direct injection, this one right here. There's 2 advantages to both. First, let's go over port injection. Port injection, this here is the intake port. The air will go in through this section and through the valve, which opens right here, that I believe we've talked about already. When the air is rushing through, air will be injected into this. It's Ocho, he's right here. Air is injected, fuel is injected through this fuel injector. It kind of has like little psh psh that squirts out the fuel. Yes, Ultra, I love you. And when it's done like this way, you can't get as precise of a ratio of fuel to air because you want a certain amount of fuel for a certain amount of air. With this, you can't get nearly as precise of amount as you want because it's coming in invariably. But the problem with engines is you build up carbon, which is bad for your engine over time. And gasoline actually helps clean it because it's acidic. So it cleans your intake ports when it's in there. But you can't be as precise, and you can't run higher compression ratios, which is your ratio of fuel to air. And that's port injection. So direct injection means it's injected directly into the cylinder, which is this one right here. As soon as the piston is at its top point and the air is hot, the fuel is injected and the spark plug makes sparks which ignite it. This means you could run higher amounts of horsepower and torque because you're able to more precisely control this, but it doesn't have that cleaning effect on your intake ports, which means you're gonna have to repair your engine due to wear more and more often. You get me? Okay, let's talk a little more. So I think that's all I have for that in basic car vocabulary. I'll talk to you guys later.